In this video, we'll talk about the probability of union, intersection, and complement of events. Let's say we have two events, A and B, and they take place in the sample space S, and this is a Venn diagram representing the relationship between A, B, and S. We can see here event A has 40 plus 20 simple events. Event B has 20 plus 15 simple events. A and B has have 20 elements in common, and there are 25 simple events in the sample space that are not in A or B. First, I want to find the probability of A union B. And this should be equal to the number of elements in the set A union B over the number of elements in the sample space. How many elements are in the set of A union B? Well, we have 40 and 20 and 15, right? We add them up, so it's 40 plus 20 plus 15 over the number of elements in the set S, which is the sample space. So it's also those three numbers plus 25. So 40 plus 20 plus 15 and plus 25. And it's 75 over 100, so the probability of A union B is 0.75. Now I want to find the probability of the event A intersect B. Intuitively, we can see the probability of A intersect B should be equal to the number of elements in the set A intersect B over the number of elements in the sample space S. So first, the number of elements in A intersect B is 20. And from here, we know the number of elements in the whole sample space is 100. So here we have 0.2 as the probability of the event A intersect B. Last but not least, I want to find the probability of the complement of the event A intersect B. Of course, here we can use the same logic we had earlier, right? The number of elements in the set of the complement of A intersect B should be the number of elements that are not in the intersection of A and B. So it will be 100 minus 20 here and over 100, so it's 0.8. This is one way to see it. Another way to solve this problem is to use the fact that the probability of the complement of event E is equal to 1 minus the probability of event E. Because the probability of event E plus the probability of the complement of event E is equal to 1. We can say this is because E and E complement are disjoint event and their union is the sample space. Or you can say the universal set, right? So the probability of the universal set is 1. So using that property of the complement event, we can write the probability of the complement of A intersect B as 1 minus the probability of A, oops, it's a mistake, intersect B. There you go. Okay, so we already know the probability of A intersect B is 0.2, so it's 1 minus 0.2, and we get the same answer as the other method, which is 0.8. This is the end of this video, and I hope this is helpful, and I will see you in the next video.